Question 1. Which of the following is the most effective method for reducing patient exposure to radiation during dental radiographs? A. Using a lead apron only. B. Increasing the kilovoltage, kVp. C. Using the fastest image receptor, e.g., f-speed film or digital sensor. D. Decreasing the source-to-film distance. Answer, C. Using the fastest image receptor, e.g., f-speed film or digital sensor. This question focuses on radiation protection and the most effective way to minimize a patient's radiation dose. The key is understanding that faster image receptors require less radiation exposure to produce an image, thus significantly reducing the patient's dose compared to slower options. For example, switching from D-speed to F-speed film can reduce exposure by about 20%, and digital sensors can reduce it even further. Remember, using the fastest receptor possible is a cornerstone of the ALARA principle, as low as reasonably achievable, to protect your patients. Question 2. The primary purpose of the aluminum filter in an X-ray tube head is to A. Restrict the size and shape of the X-ray beam. B. Remove long wavelength, low-energy X-rays from the beam. C. Absorb scattered radiation from the patient. D. Cool the X-ray tube during exposure. Answer, B. Remove long wavelength, low-energy X-rays from the beam. This question tests your knowledge of X-ray tube head components and their functions, specifically the aluminum filter. The crucial insight is that long wavelength, low-energy X-rays do not contribute to diagnostic image formation but are instead absorbed by the patient, increasing their radiation dose unnecessarily. The aluminum filter acts like a sieve, filtering out these harmful, non-diagnostic photons, allowing only the useful, higher-energy X-rays to pass through to the patient. Think of it as protecting the patient from radiation that would only harm them without providing any useful information for the dentist. Question 3. What is the recommended angulation of the central ray for the paralleling technique? A. Perpendicular to the bisector of the angle formed by the tooth and the film. B. Parallel to the long axis of the tooth and perpendicular to the image receptor. C. At a 45-degree angle to the occlusal plane. D. Directed toward the apex of the tooth at all times. Answer, B. Parallel to the long axis of the tooth and perpendicular to the image receptor. This question assesses your understanding of the paralleling technique, a fundamental concept in dental radiography. The key to the paralleling technique, as suggested by its name, is ensuring the image receptor and the long axis of the tooth are parallel to each other. Consequently, the central X-ray beam must be directed perpendicularly to both the tooth and the receptor to minimize distortion and produce an accurate image. This precise alignment helps avoid common errors like foreshortening or elongation, providing a diagnostically superior radiograph. Question 4. A lead apron should be used on all patients for all intraoral and extraoral radiographs primarily to protect which body part? A. The hands. B. The thyroid gland. C. The reproductive organs. D. The eyes. Answer, C. The reproductive organs. This question addresses a critical aspect of patient radiation protection, specifically the role of the lead apron. While a thyroid collar protects the thyroid gland, the lead apron's primary and most significant function is to shield the patient's radiosensitive reproductive organs and other vital tissues in the torso from scattered radiation. This is a fundamental component of the ALARA principle, ensuring that unnecessary radiation exposure to these sensitive areas is minimized. Always remember that the lead apron offers broad protection for the trunk of the body. Question 5. Which of the following conditions would result in a radiograph that is too light, underexposed? A. High kilovoltage, kVp, setting. B. Excessively long exposure time. C. Insufficient milliamperage, mAh. D. Short developing time in the automatic processor. Answer, C. Insufficient milliamperage, mAh. This question tests your knowledge of exposure factors and their impact on image density, specifically what causes an underexposed, light, image. Milliamperage, mAh, directly controls the quantity of X-rays produced. Therefore, an insufficient mAh setting means fewer X-rays reach the image receptor, resulting in a lighter image. For example, if you set the mAh too low for a given tooth and patient size, the resulting radiograph will lack the necessary darkness to be diagnostically useful. Always remember that inadequate mAh reduces the overall density of the image, making it appear too pale. Question 6. The ALARA principle states that all radiation exposure should be kept. A. As low as readily applicable. B. At the highest acceptable level. C. As low as reasonably achievable. D. At a standardized exposure level. Answer, C. As low as reasonably achievable. This question directly tests your understanding of the foundational principle of radiation protection in dentistry. ALARA. The acronym stands for As Low as Reasonably Achievable, emphasizing that every effort must be made to minimize radiation exposure to patients and operators, even if the exposure is already within safety limits. This principle guides all aspects of radiographic technique and equipment usage, ensuring that diagnostic benefits outweigh any potential risks. For example, using proper shielding, faster receptors, and accurate technique are all applications of the ALARA principle in practice. Question 7. What is the main disadvantage of the bisecting angle technique compared to the paralleling technique? A. It requires a longer exposure time. B. It produces more dimensional distortion. C. It is more uncomfortable for the patient. D. It is more difficult to learn and perform. Answer, B. It produces more dimensional distortion. This question assesses your understanding of the relative merits and drawbacks of two primary intraoral radiographic techniques. The core concept here is that the bisecting angle technique inherently relies on geometric estimation to minimize image distortion, which makes it more prone to inaccuracies in image length and width compared to the precisely aligned paralleling technique. Since the receptor is often placed closer to the tooth and at an angle, foreshortening or elongation can easily occur if the central ray isn't aimed perfectly at the imaginary bisector. Therefore, while often more comfortable for patients with challenging anatomy, it typically yields less dimensionally accurate images. Question 8. The quantity of X-rays produced is controlled by A. Kilovoltage, kVp. B. Exposure time. C. Milliamperage, mAh. D. Both exposure time and milliamperage, mAh. Answer, D. Both exposure time and milliamperage, mAh. This question probes your knowledge of the factors that determine the quantity, number, of X-ray photons generated during an exposure. Both milliamperage, mAh, and exposure time contribute directly to the total number of X-ray photons produced, as their product defines the milliampere seconds, MOS, which is a measure of the total X-ray energy. If you increase either the mAh or the exposure time, more electrons are accelerated across the tube, resulting in a greater quantity of X-rays hitting the target. Think of it this way: mAh controls the rate of electron flow, and time controls how long that flow occurs, so together they determine the total amount of X-rays. Question 9. In dental radiography, The inverse square law states that the intensity of radiation is A. Directly proportional to the source-to-film distance. B. Inversely proportional to the source-to-film distance. C. Directly proportional to the square of the source-to-film distance. D. Inversely proportional to the square of the source-to-film distance. Answer, D. Inversely proportional to the square of the source-to-film distance. This question tests your understanding of a fundamental principle governing radiation physics, the inverse square law. This law explains how radiation intensity changes with distance from the source. The crucial point is that as you move further away from the X-ray source, the radiation spreads out over a larger area, causing its intensity to decrease significantly, specifically by the square of the distance. For example, if you double the source-to-film distance, the intensity of the X-ray beam reaching the film becomes 1/4 of its original intensity. This principle highlights why operators should maintain a safe distance from the X-ray tube head during exposures. Question 10. What is the maximum permissible dose, MD, for an occupationally exposed dental professional per year? A. 0.5 SV, 50 rem. B. 50 mSv, 5 rem. C. 5 mSv, 0.5 rem. D. 1 mSv, 0.1 rem. Answer, B. 50 mSv, 5 rem. This question focuses on occupational radiation safety limits, a critical component for dental professionals working with X-rays. The key is knowing the specific annual maximum permissible dose, MD, set for individuals who are exposed to radiation as part of their job. This limit is established to ensure that the risks of radiation exposure remain acceptably low over a professional's career. This MPD does not include medical or natural background radiation, only that received from occupational activities. Always remember this specific limit to maintain your safety and compliance in the dental office. Question 11. Which processing error causes a dark or black image with a visible film edge on a film-based radiograph? A. Underexposure. B. Overlapping films in the processor. C. Developer cutoff. D. Fixer cutoff. Answer, C. Developer cutoff. This question evaluates your knowledge of common darkroom processing errors that affect film-based radiographs. Developer cutoff occurs when the film is not fully immersed in the developer solution, resulting in the part of the film that was not immersed remaining unprocessed. Since the developer solution is responsible for initiating the chemical reaction that darkens the exposed silver halide crystals, the undeveloped portion of the film will appear clear or very light, while the developed portion will be dark with a sharp, straight line demarcation. This creates a distinct visual clue, a straight, clear border, on the radiograph, indicating insufficient developer coverage. Question 12. The term that describes the unit of measurement for the total amount of radiation energy absorbed by a tissue is A. Röntgen, R. B. Sievert, SV. C. Gray, GY. D. Rem, Röntgen equivalent man. Answer, C. Gray, GY. This question tests your understanding of the various units used to measure radiation and their specific applications. The key distinction here is that Gray, GY, is the unit of absorbed dose, meaning it quantifies the amount of radiation energy deposited per unit mass of tissue. While Sievert, SV, relates to the biological effect of radiation and Röntgen, R, measures exposure in air, Gray directly reflects the energy absorbed by the patient's tissues. Think of Gray as a measure of how much energy the body actually took in from the X-ray beam. Question 13. What is the purpose of a collimator in the dental X-ray tube head? A. To remove long wavelength X-rays. B. To cool the X-ray tube. C. To restrict the size and shape of the X-ray beam. D. To increase the intensity of the X-ray beam. Answer: C. To restrict the size and shape of the X-ray beam. This question assesses your knowledge of the components of a dental X-ray unit and their specific functions, focusing on the collimator. The collimator is designed to narrow and shape the X-ray beam, reducing the area of the patient's head exposed to radiation and thereby minimizing unnecessary scatter. By creating a smaller, more precise beam, typically a rectangular or circular shape, it significantly reduces the patient's overall radiation dose. Always remember that a smaller beam means less patient exposure, directly aligning with the ALARA principle. Question 14. Which of the following factors affects the penetrating power of the X-ray beam? A. Milliamperage, mA. B. Exposure time. C. Kilovoltage, kVp. D. Film speed. Answer: C. Kilovoltage, kVp. This question probes your understanding of X-ray exposure factors and how they influence image characteristics, specifically beam penetration. Kilovoltage, kVp, directly controls the energy and quality of the X-ray beam. A higher kVp produces X-rays with shorter wavelengths and greater penetrating power. This means the X-rays can pass through denser tissues more easily, affecting image contrast and density. Think of kVp as the force or strength of the X-ray beam, determining its ability to get through different structures. Question 15. What is the most common cause of blurred images, motion unsharpness, on a radiograph? A. Improper film processing. B. Insufficient kilovoltage, kVp. C. Patient movement during exposure. D. Excessive source-to-film distance. Answer: C. Patient movement during exposure. This question focuses on common factors that degrade image quality, specifically leading to blurred radiographs. The most frequent and direct cause of motion unsharpness is any movement by the patient, the image receptor, or the X-ray tube head during the short exposure time. Even slight shifts can cause the sharp edges of anatomical structures to smear across the image. To prevent this, always ensure the patient is comfortably positioned and instructed to remain still throughout the entire exposure. Question 16. A radiograph that appears very dark overall with little difference between light and dark areas is described as having A. High contrast and low density. B. Low contrast and high density. C. High contrast and high density. D. Low contrast and low density. Answer: B. Low contrast and high density. This question tests your ability to interpret radiographic appearance based on technical factors. A radiograph that is very dark overall indicates high density, meaning it received excessive X-ray exposure or was overdeveloped. When there is little difference between the light, radiopaque, and dark, radiolucent, areas, it signifies low contrast, indicating that most structures are shades of gray rather than distinct black and white. Think of a very dark image where everything looks murky and blended. That's high density with low contrast. Question 17. Which component of the X-ray tube generates the electrons that produce X-rays? A. Anode. B. Tungsten target. C. Cathode. D. Focusing cup. Answer: C. Cathode. This question delves into the fundamental components of the X-ray tube and their roles in X-ray production. The cathode is the negatively charged electrode containing a tungsten filament that, when heated, releases electrons through a process called thermionic emission. These electrons are then accelerated towards the anode, where they impact a target to produce X-rays. So, remember, the cathode is the electron source that kicks off the X-ray production process. Question 18. What is the appropriate film storage condition for unexposed dental X-ray film? A. In a warm, humid environment. B. Near the X-ray unit for easy access. C. In a cool, dry place shielded from radiation. D. Exposed to indirect light to prevent fogging. Answer: C. In a cool, dry place shielded from radiation. This question highlights the importance of proper film handling and storage to maintain image quality. Unexposed dental film is highly sensitive to heat, humidity, light, and stray radiation, all of which can cause film fogging and degrade image clarity even before exposure. Storing film in a cool, dry, and radiation-safe environment ensures that the silver halide crystals remain in their original state, ready to capture a sharp, diagnostic image when exposed. Think of film as being very picky about its environment to perform its best. Question 19. A radiograph shows unexposed areas, appearing clear or white, where two films were stuck together during processing. This error is known as A. Film scratching. B. Reticulation. C. Overlapping films. D. Air bubbles. Answer: C. Overlapping films. This question focuses on identifying a specific processing error based on its visual characteristic. Overlapping films occur when two or more films touch each other during either the developing or fixing stages in the automatic or manual processor. The areas where the films overlapped prevent the processing solutions from reaching those surfaces, leaving them undeveloped and therefore clear or white on the final radiograph. This creates distinct, unexposed patches on the film where the solutions couldn't penetrate. Question 20. When taking a panoramic radiograph, the patient's chin is positioned too high, resulting in an image with A. An exaggerated smile line and broad, blurred maxillary incisors. B. A V-shaped mandible and blurred condyles. C. A reverse smile line and blurred, widened maxillary incisors. D. Mandibular incisors that appear too long and narrow. Answer: C. A reverse smile line and blurred, widened maxillary incisors. This question tests your knowledge of common errors in panoramic radiography and their distinct visual outcomes. When the patient's chin is positioned too high, chin tipped up, the X-ray beam passes through the maxilla at an incorrect angle, causing the maxillary incisors to appear blurred, widened, and elongated. This also results in a reverse smile line or sad face appearance of the occlusal plane on the final image. Correct patient positioning is crucial for avoiding these predictable distortions in panoramic radiography. Question 21. Which type of radiation has the ability to cause ionization in matter? A. Radio waves. B. Visible light. C. X radiation. D. Microwaves. Answer: C. X radiation. This question addresses the fundamental nature of X radiation and its interaction with matter. Ionization is the process where an atom gains or loses an electron, thereby acquiring an electrical charge, and X radiation is a type of ionizing radiation. This ability to remove electrons from atoms is what makes X-rays capable of causing biological damage in living tissues, necessitating stringent safety protocols. Remember that the term ionizing radiation is a key characteristic of X-rays and defines their potential effects. Question 22. What is the primary advantage of using a rectangular collimator over a circular collimator? A. It produces a smaller focal spot. B. It significantly reduces patient radiation exposure. C. It is easier to aim the X-ray beam. D. It provides greater image contrast. Answer: B. It significantly reduces patient radiation exposure. This question highlights a crucial aspect of radiation protection related to collimation. A rectangular collimator restricts the X-ray beam to the approximate size and shape of an intraoral film or sensor, reducing the exposed area of the patient's face by up to 60% compared to a traditional circular beam. This targeted exposure significantly minimizes unnecessary radiation dose to surrounding tissues, making it a superior choice for adhering to the ALARA principle. Always prioritize using rectangular collimation when possible to enhance patient safety. Question 23. An image receptor that is placed too far from the tooth will result in an image that is A. Foreshortened. B. Elongated. C. Magnified. D. Distorted due to overlapping contacts. Answer: C. Magnified. This question tests your understanding of projection geometry in dental radiography. When the image receptor is positioned too far from the tooth, the X-ray beam diverges more before reaching the receptor, causing the image of the tooth to appear larger than its actual size. This effect is known as magnification. To minimize magnification and produce a more accurate representation, the image receptor should be placed as close to the object, tooth, as anatomically feasible, especially with the paralleling technique. Question 24. A dental assistant should stand at least how many feet away from the X-ray tube head during an exposure? A. 3 feet. B. 6 feet. C. 9 feet. D. 12 feet. Answer: B. 6 feet. This question addresses a fundamental safety guideline for occupational radiation protection. Standing at least 6 feet away from the X-ray tube head during an exposure is crucial because radiation intensity decreases significantly with distance, as explained by the inverse square law. This distance ensures that the operator receives a minimal amount of scattered radiation, protecting them from unnecessary exposure. Always remember that distance is your best friend when it comes to minimizing occupational radiation dose. Question 25. What is the main function of the fixer solution in film processing? A. To convert silver halide crystals into metallic silver. B. To remove unexposed silver halide crystals from the film emulsion. C. To harden the film emulsion. D. To rinse residual developer from the film. Answer: B. To remove unexposed silver halide crystals from the film emulsion. This question delves into the chemical processes involved in manual or automatic film processing. The fixer solution's primary role is to fix the image by dissolving and removing the unexposed and undeveloped silver halide crystals from the film emulsion. This process stops the development, hardens the emulsion, and leaves only the black metallic silver that forms the diagnostic image, preventing the film from turning dark over time. Think of the fixer as clearing away the ghosts of the unexposed silver, leaving a permanent, readable image.